All right. Welcome to another meetup here. We have a new guest here. Jed, do you want to briefly introduce yourself if you want?
Hey guys. Yeah, my name is Jad Wahab. I'm working at nChain for a couple of years now, as a software engineer. I started doing some work with research, and then I went back to, so my background is computer engineering. So then after spending some time in the research team, I moved back over to the engineering team. And a couple of years I've been working on mainly Kensai and a lot of infrastructure stuff, most recently the light client stuff and a bunch of SPV tooling.
I see. Cool. Awesome. So I don't know, shall we do this for everybody quickly, or we can just move?
Yeah, that would be nice.
Yeah, let's do it quickly then. Kevin?
Yeah, so I'm I don't even know how to introduce myself anymore. Let's see, I was an independent app developer for iOS, and I still am for ever since I finished college, which was back in 2012 or 13 or something like that. No, I think it was, well, anyways. And then I got interested in investing in Bitcoin back when it was, just a speculative investment, like 2015. And then I just got more and more interested in the space. And so now I'm researching. One of my passions has always been healthy lifestyle and eating. And one of the things that needs to happen, what I'm focused on now, is just how do we use the blockchain to kind of do all sorts of stuff related to keeping track of food and stuff like that. It's a whole long story. I don't want to talk your head off, but that's what I'm working on. But it's a long-term vision, maybe like 10, 30 years. So I'm not in any rush. So that's who I am. I'm in San Diego too.
Cool. Yeah, I think most people probably in BSV know about Kevin because his video. If you haven't seen it, I strongly recommend it. Yeah, because basically,
is that the one about Ethereum or something?
Yeah, I was.
I think I remember that. Yeah,
I did an Ethereum video. I was just interested in it, and there's nobody to talk to, and so I did a YouTube video, and then it became popular. But then recently, I did a video defending Craig, saying why I think he's Satoshi. And then it was more popular than I was expecting. And then, so.
Cool.
Yeah.
I think I have a similar story with Ethereum as well. It's been like a year. So I got my master's at UCL and, going through all of the sort of blockchains from Ethereum to, at the times, mainly BTC and, a lot of work around the Lightning Network. There's a bunch of professors there, Zcash, stuff like that. And we even, analyzed Cardano's Ouroboros. It's like a monstrous, 40-page white paper around.
That's not long, man. That's not long. 40 pages.
Well, the Bitcoin white paper was apparently 60 pages, right? So
yeah, I think it's more than. The longer, the better. That's what I heard. The lightning is like,
yeah. I mean, if you read the Ouroboros one, it's like, it's pretty like convoluted. So I think a lot of people have similar journeys where they, go through a lot of Ethereum, IOTA even. EOS,
that's what I've been doing.
Cardano, Avalanche, the whole thing, and then Hyperledger Fabric as well, a lot.
Solana right now. So
right now, Solana.
Internet Computer is another.
ICP, Infinity.
Yeah, you slowly realize that bitcoinsv is the one with the best chance of getting there, and I'm sure I don't have to mention this to everyone. Everyone is convinced that only one sort of blockchain will make it, and it doesn't make sense to have more than one. And then bitcoinsv is obviously the most likely candidate out of everything. But yeah, I guess if you guys are in the sCrypt chat Slack, then I'm like preaching to the choir.
Yeah, so we already conversed, so that's a good thing. So why don't we just keep this ball rolling? So I don't know, Ty, you want to be just, because Jad is new here, so you want to quickly like a 1 minute or 30 seconds?
Yeah, I mean, I think
yeah, I've done a
let's
bunch
see.
of work with Ty as well. So
yes,
we did some things also. But yeah, so my name is Ty Everett. I've worked on stuff with Project Babbage. Basically, what I'm doing here is writing a whole bunch of code that I think is cool. And I have a feeling that there are some other people who also think that it's cool when it's done. So going through that process and building a project on top of that includes, building overlays on top of Bitcoin, SPV stuff, content storage, just providing the tools needed to build applications on top of Bitcoin. And there's some tutorials I've been making about showing people how to do that stuff. So that's kind of who I am and what I'm doing here.
Babbage, right? Babbage.
cool.
I'm Bill. I'm in New York. I'm working on a project. I'm a BSV maximalist.
Okay.
Yeah, I'm in stealth mode working on sort of like a browser, and going well. And I love this sCrypt, and yeah, I'm having a lot of fun working on this, and I have nothing but I'm very hopeful, but I don't know what the time frame is. That's very uncertain for me. Welcome.
Me too. The timing is very difficult, but I've never been worried about the timing. It's just, as long as I'm having fun now, then it's all good.
Time shifts and flattens, days and decades folding aside like pages in a book. And if anybody can source that quote, I will be very surprised.
Wow, very poetic. So that's good.
I actually don't know where it came from. I know it came from somewhere. I didn't make it up, but
okay.
I actually don't know where it is. So someone please let me know if you know where that quote came from.
Okay.
Hey, Jade, go by Jad?
Jad, yeah.
Jad. Oh, Jad. Okay, yeah. My name is Samir, and I don't know. I'm just an enthusiast, and how Bitcoin really solves the problems and so forth. And I think I do have a branding company, so basically educating entrepreneurs and like newcomers that are trying to get into Bitcoin, and how their business is basically how can they incorporate Bitcoin and its philosophy, the principles into their businesses. So it could be pretty much anything, right? So I have that company, and I just educate people and do conferences, meetups, and I like this group here because I'm not a developer. I used to be a developer, but not so fluent at it. But I see a lot of folks here who build stuff, and it's really, I'm really intrigued by their work. So I'm just trying to get in, try to know what everybody's doing, so that we can kind of like build something kind of like together. So yeah, that's where how I am going to contribute. But yeah, Ty's Project Babbage is really cool. I've just gone through Kevin's profile as well, like the Meal Cam. I just saw that app. I haven't downloaded it because I have an Android. It's an iPhone app. And sCrypt, of course, there's so much to learn there. But yeah, I'm just trying to get in, know everybody, and just trying to help and contribute in this space. And I'm since my research for the last few years, Bitcoin SV is definitely there at the top, to make it as that one global blockchain. I'm a believer of that as well. And also I have a similar confusion in terms of the timing, but it doesn't really worry me because I think I'm heading to a right path. That's what I feel. So yeah, that's what it is.
Very well.
Cool. Nice to meet you.
Yeah, by the way, Samir is like, if Ty is a poet of this group, like Samir is more like a philosopher kind of thing. Yeah, because he usually goes very deep. So if you have seen some of the past videos. Okay, cool. Mike?
Hey, good afternoon,
Scott?
guys. How's it going?
Very good, very good.
Happy to be here.
Welcome. You want to just briefly introduce yourself?
Yeah, absolutely. So apologize I couldn't make the past several sessions. I've been following
No problem.
your channel for probably about a year, actually, over since it started. I've been involved with Bitcoin since 2013. Have been following kind of the initial promise of blockchain, right? And tracing that all the way through where we are today has kind of led me down the rabbit hole a lot of us have gone through in terms of understanding who Craig Wright is, understanding kind of the impetus of the technology. And for me, I've always been a big blocker. Never really understood why there was even a debate to begin with. And have been involved in some other blockchains as well. But everything that I've studied has led me back to the Satoshi Vision, BSV. So very passionate about the technology. I'm an avid investor as well as technologist. So I've actually invested in some hardware to start kind of tinkering around with, some of the Bitcoin D software, just from a listening node perspective. So here to learn, not too technical. Have a background in business development and sales, as well as supply chain management with some of the largest companies in the world. I've worked for Fortune 100, Fortune 1000 companies in the past, and I'm in the technology space and happy to be here.
Okay,
Cool.
welcome.
That's me.
Very good. Where are you based, if you don't mind?
I'm in the Washington, D.C. region.
Oh, okay, cool.
Cool. Do you guys usually have like an agenda for the meetings, or it's just like a informal kind of thing?
We have
There were some proposed topics, I think.
Yes. So we try to do that first, and then usually it's not strictly followed, so we can just go. But first, I want to do like some kind of like, usually I do some kind of like a house cleaning. I just want to every week I give some update on at least the sCrypt, because what kind of new features, what kind of new contracts we have released, so people can have know what we are up to, and then we go to the proposed topics, and then usually it goes like too broad than what it used to be, but that's the nature of this. It's kind of informal, yeah. But anyway, we can get started right now, and if you have anything you want to jump in or interrupt, and it's pretty freestyle, yeah.
Yeah, cool. I don't want to intrude, so I'll.
Yeah, you're more than welcome to.
Let's stick to
the
agenda.
Yeah. Okay. Let's come back to the. Okay. So first, always some like a house cleaning. So I want to briefly talk about what we have. Some of the things we have done this week. So for guys who have been interested. So the number one way to keep an eye on what the status of sCrypt is, or new kind of a contract, I strongly recommend you go to our blog. So basically, if you go for people who hasn't seen this, you can go to sCrypt.io and then click the blog. It will take you here. So I think I want to. Okay, my computer is a little bit slow. Okay, you guys see me okay?
Yep.
Oh, okay. I think I clicked something. Okay, so the first thing is, so about 2 days ago, we released this new article. So basically it's the part 5 of the series, which basically, I mean, we have a few experts here, SPV, like Jad and Tai. So basically this is how do you do kind of like SPV, but on chain in sCrypt or in bitcoinsCrypt. So the basic idea is because of the nature of proof of work, it's very hard. If once you get the block headers, it's very hard to. It's not impossible, but usually you can design such that it's economics secure. You can verify the headers in a very confident way. So you can, once you have the block headers, you can know the transactions. You can know a lot of other information as well. So here, built upon the 4 parts we released about 1 or 2 weeks ago. So we have another concept called relative log time. So basically, this is you can think of for people who have been familiar with Bitcoin script or BTC script, whatever, if I could refer. There's a opcode specific called object sequence verified. So basically, what this does is you log some coins in a relative time. So before, for people who have no object time log of CLTV, check log time verify. So that in that sense, there's we call it absolute time lock, because you can only say we lock up some funds maybe to a certain time or to a certain block height, right? But you cannot say once I lock this fund, you cannot spend it until 5 blocks has piled upon it, or maybe have 1 week has passed, right? But that can be useful for a lot of other cases, and usually it's thought of impossible without this new opcode, because in the Genesis we remove this code. So here we introduce a way how you can do equivalent without introducing the new opcode. It's kind of like a recurring scheme for us, because we have time and time again, somehow we have shown, it's kind of also surprising to me, even myself, a lot of times the new opcode is, I think at least I have 10 opcode now, is you can actually, you don't need a new opcode. You can just re-implement the same thing with the existing opcode. It's almost if the original Bitcoin is very, it's designed very well. So how does this work? So basically, it's similar to the log time we have seen before. So for people who have not seen this object seek verify, usually called CSV, is basically it passes a parameter. This parameter tells the contract what's the earliest time it can be unlocked in terms of the relative time. For example, let's say 10 blocks into the future after this transaction is mined, or 1 week into the future. And so you could imagine this actually is a foundation for a lot of like a BTC or even a BCH application. The most famous one is Lightning, right? You can also have side chain or some kind of like a non-Nakamoto style payment channel as well. But they're claiming you cannot do this without this opcode. So how do we implement this opcode? Is also, if you are familiar with the work for all the previous parts we have released, so it's actually kind of straightforward. So how we do it? Well, first we can find out which block the transaction has been mined into, because we can use the technique called the outpush transaction. So we can have the transaction ID for the previous transaction, and through the transaction ID, through the SPV Merkle proof, we can know which block it is in. And also in another technique, if you know which block you are in, you can know the time, and also you can know the height of the block as well. So this all covered in the previous series. So once you have this, you can add the delay, and then you know what's the earliest block, either in terms of height or in terms of absolute time that can be incorporated into the blockchain. So this is definitely for anybody who's familiar with sCrypt code. So you can just go through this. Not very long. It's only like if you don't count the comments, probably like less than 40 lines. So it's also always published in our GitHub repo. So I strongly recommend you to check into this. So I think I'm going to kind of like a spoiler alert. I'm going to release another very cool smart contract after this meeting. So definitely check this out. Basically use this very good trick to implement something I think it could be very practical, and a lot of people can use it. So stay tuned. Any question about this kind of off CSV so far?
Back in the day, it was when you recommended that NAND to Tetris. And I don't claim to understand all of it, but I did take that course. I didn't do all the exercises, but I watched pretty much all the videos. And yeah, it seems like we just have, like, I look at the opcodes as sort of like the logic gates. and they're organized in like an abstract enough way where you could build all these other pieces. So that's cool.
You're building up the various layers of the system, it seems. I mean, from my understanding, just make sure this is correct, but this opcode allows you to create a script that locks up coins, and those coins can then not be unlocked until some future block height. So in 5 blocks or in 5 days.
Yeah, all time. It can be also in the next until next week. Yeah. You cannot be spent until next week. Yes.
So you can combine this. You can combine this with you could combine this with outpush TX and stipulations on output amounts in the transaction to have a running contract that says, well, you can unlock this in maybe 1 month if condition A is met and you get 100% of the value. Or if that doesn't happen, then in 2 months you could take out 50% of the value if a second condition is met, and then it would force the other amount to go back into the contract, which kind of repeats itself how you do with those kinds of things, and then allows half of them to be freed up. So I think you could combine it, if I'm not mistaken, in such a way that either you have value that increases over time, going from like 0% of the locked up UTXOs or locked up Satoshis to 100% that are able to be kind of taken out when you redeem the contract, or decreasing over time, or some combination thereof. I guess you could even build like a sine wave where the value starts going up and then it goes down as far as the amount of time you can get before you redeem it. I think that would be, I'm just thinking like to combine those two concepts. I think that would be possible. I'm not sure though.
Yes, I think definitely possible.
So you had an article before this where you introduced the idea of entering block headers and all that.
Yes.
So I'm a little unclear, like game theory wise, how it's really trustworthy. So if I am if I'm a miner and I'm competing with other miners and I decide to go rogue and then I branch off and I mine a block, but the rest of the world has gone on. All the other miners have advanced. And this contract was written before I branched off. And now I've got a block, but it just took me a really long time to find it, much longer than 10 minutes. And the rest of the world has gone on, but this contract was written 2 days ago. Can I present my block header? And if no one else knows about this contract, someone wrote a contract, saying that that 10 minutes from now or 5 minutes ago, it could be spent. Now prove that the time has elapsed. So here I have proof that time has elapsed. Yes. The rest of the world is ignoring this contract, or they don't know about it. They didn't notice it, but I did. And I branched off. I have a block, but no one cares about my block because, so why can't I produce that as proof? If I'm the first one to the party and I use my block.
Yeah, very good. Yeah, very good question, actually. So actually we, in the previous series, we kind of addressed this issue. So this is called a fake block headers attack, right? Because in theory, there's nothing technologically, there's nothing prevent you to just produce some headers off the main blockchain, right? You can just pass in, and then you can fool the contract to think, because the contract does not know the external world, right? Because the whole point for this scheme is we don't rely on any trust third party or oracles. So how do we verify that? So it's the same thing with let's say SPV or like a zeroconf or even mining. It's never going to be 100% because it's based on economics. So basically, when you're checking any block headers, you can define what's the minimum difficulty this one must have to make sure is expensive. It's not impossible, but it'll be expensive to attack. So on top of this, you have two ways to tune, right? So basically, one, you can increase the difficulty level. Let's say, this block header, any block header must have, I don't know how many leading zeros on the main chain right now. Let's just say 100 zeros, right? You can do it. So you have two ways, right? Either you can take a legit block header from the main blockchain, a plugin, right? Then it's free, right, for you, for the attack, for the legit use case. But if you want to attack it by faking it, you have to find this. You have to mine this block, as you said, right? So it's expensive. So how do we alleviate this problem? You always have to make sure the funds that's locked up in the contract is no more than the block reward. Is smaller than the cost for you to produce this fake block header, because you can do it, but usually people don't steal your one Bitcoin by faking, a block header which takes maybe 6 block Bitcoins to produce. Make sense?
Good answer.
So,
yes, thank you.
Yeah, that's one part. You can tune this parameter, and also we have another way. Basically, you require, it's almost like a confirmation, right? So you can, instead of just pushing one block header, you can require it to push a chain of block headers, right? And then you just use the first one, or the following ones, you can think about the confirmation, right? Then it makes it even harder. But again, it's also tunable. You all can, depends on, for example, if you're just buying some like, I don't know, $1, digital goods or NFT, whatever, from some marketplace, you probably don't worry too much about it. But if you're like buying a house, you may want to push, I don't know, in the extreme case, you want to push all the block headers since Genesis, right? It's even possible, right? It's like how many megabytes, right? So it's not, if you really, depends on how the value of the contract will be locked up. So the more you want to make it more difficult, and also you can always push more block headers, right?
Very good.
Okay, makes sense?
Yeah, I think that was my initial
yes. Okay.
Yeah.
Like
when I first,
Eureka moment.
My initial reaction, because with SPV you have to not just check the SPV, you have to check that it's in the longest chain as well. So if as Chaowei says, in the script, you would have to push the current difficulty of the block header. So I guess you'd have to put it in the unlocking script manually, and then similar to block confirmations, you would have to say, for example, because like I think your initial post was around like a fair toss. So let's say you had a fair toss, and if the nonce was even, one person would win, and then if it was odd, the other person would win. And then let's say there was a fork on the chain at that specific block height, and then one of them, one of the block nonces was even, and the other one was odd. Technically, they both satisfy like the the SPV proof. But as Chaowei says, you would then increase the difficulty, saying you'd need, let's say, 6 block confirmations or something like that, and then the probability of having 6 block reorg, it decreases a lot, and it kind of fits in with on BTC, people say you need to wait 6 block confirmations, but where did that number 6 come from? It's just like an arbitrary number, and you have to sort of weigh out. There's no such thing as like 100% security. You have to weigh out the risks and say, if you're sending like a coffee, paying for a coffee, 0 conf is more than enough security. And then if you're buying a house or something, it's not like you're gonna move in like 2 minutes. So I guess it's the same concept here.
Exactly. And getting back to a little bit of the philosophical point of view for Samir, and also the Kevin's example, from NAND to Tetris. For people who haven't not seen this course, I'm going to send the link later. So basically, the BSV approach or the regional Bitcoin approach is almost like this Bitcoin virtual machine, right? It has a given instruction set. You don't usually, it's like x86 or ARM, right? Or let's say even JavaScript virtual machine. Usually you don't, so when you want to design some kind of a new software or algorithm, like what we see here, right? Like lock up some files, or even say check some, push transaction. You want to know the pre-image, right? So one way to do it, you can always have the option to add a new opcode, right? That's what other chains are doing, the BTC and BCH, right? For example, or to the extreme, right? Ethereum, right? In kind of sense, right? Because they kind of just throw, I don't know, 100 more opcode into the original script opcode. So then which they claim is more powerful, right? That's all. You can always do that, right? That's what the BTC and this altcoins has been playing with. But it's almost, but in reality, right? It's in hardware. For example, once like some kind of like Intel chip have shipped, right? When you want to develop some application on top of it, using it, usually you don't change the instruction set, as it's almost ever, right? So before you change, the philosophy for us here is before you really want to add a new opcode and change everything, you really want to make sure is it possible to do it using the original instruction set? And it seems it's much more powerful than I think most people, including me, have thought. Because, for example, there's CSV, right, op CRTV, or op Schnorr signature, or even DSV, right, in BCH. So it's just kind of like a fundamental differences as what we have, kind of what we call it set in stone, right? So just some interesting comparison about different chains.
And to add to that, didn't in one of the Bitcoin classes, or maybe it's Theory of Bitcoin, it was talking about how I don't know if it was Forth or it was these instruction sets or something, but it was designed around some sort of chip that's now out of patent, but it was very reliable or whatever back in the 80s or 70s or something. So yeah, I mean, I don't see what the advantage, if you can build something with the base elements, then why would you introduce a new base element that does something like these other blockchains are doing? Maybe, I guess, I've always, if you want to make it super efficient, then you can bring it down to the lower level, but I don't know. I don't understand this that well enough to really have a good conversation about this, but I'm very interested in it. But that course, NAND to Tetris, is really good. I recommend it for people that are interested in the lower levels of how computers work.
I think one of the things that kind of comes to mind is I don't think, in the same way, like Xiaohui, you were mentioning, the capabilities of Bitcoin script are beyond what even you originally, as somebody who knows about it probably more than almost everybody else, the capabilities are more than what you originally expected. And I would say in the same way, I bet the people that, what was it, 40, 50 years ago now, designed x86, the architecture, they were not expecting us to be able to run, live streaming video application that works in real time on top of it. And they just didn't have that in mind. But because of the open-ended nature of the architecture itself and the ability to create, building blocks on top of it, optimize the lower layers, now we have better, fabrication capabilities for these chips that allow them to be more efficient and run more quickly, et cetera, and ways to, basically not short circuit, but arrive at the result of execution of certain patterns of instructions very quickly, and allow these lower level optimizations. All of this stuff has become possible on top of something like x86 or ARM. And so I think that does seem like the way to go, because think about the alternative. I mean, imagine Intel, they would have to have an army of maybe 1 million engineers, and they would have to go and knock on everybody's door every year. And they say, well, we're doing a hard fork. We're adding a new opcode to x86. We need to come into your house and switch out your CPU with a new model. Can we do that? And I'm sure there's some people on the political spectrum who would say something like, well, that would create more jobs because it would have all of these engineers be going around, and they could all get paid $15 an hour to replace all of these different CPUs in every single x86 based processor in the entire world every year when they want to add a new feature. But I happen to think there's a more efficient way of doing that. And it seems very similar to the Bitcoin way of doing it.
For sure. And another thing too is every time you change all this stuff at the bottom, it breaks everything else, right?
Yeah. If you make a breaking change, if you're extending
it has to go ahead, the breaking change, and if you're extending it, if you just add, I don't want to sidetrack the conversation, but I think I kind of understand what you're talking about. I had to do this thing in core data where you could add entries to your database, but if you start removing different things, it kind of it messes it up. So I kind of understand what you meant by that. But yeah, I mean, like everything is built on top of this, and they keep on changing the protocols on these other platforms, and they just don't understand that it needs to be set in stone. It's like what Craig was talking about that I really cemented in my brain the past couple of weeks is the thing about a commodity. When you're doing trade, like the example he gave is if you want to have like a bakery or something, you rely on a certain grade of wheat or flour, I should say. And so, you need that very consistent thing to stay the same in order for you to have your consistent cake. And so it's the same with this. If you want to build all these applications on top, then the protocol has to be a specific standard that's reliable.
And bottom line, the base protocol for Bitcoin really works. It works for all use cases, as it seems. Since I've started discovering and reading about it, and you can build anything on top of it. You can beautify it any way you want, like you specifically want. But the base layer basically works. That's what I found. So I think I think that's really important.
It's just harder. It's not as easy as doing things with account-based model and
I think the person that makes the first that codes up the rules of consensus for the Ethereum network inside of a locking script for the first time. And so how this would work is you write a locking script that says, here are the rules for the Ethereum network, and this locking script can only be spent when a new valid block according to these consensus rules gets added to the end of this state variable, which is basically acting as storing the entire Ethereum blockchain. We don't put the blockchain in at the very beginning, but then you allow, well, here's block 1, you spend the UTXO forward 1 time. Here's block 2, spend it forward a 2nd time. And you could write all these constraints in, and suddenly you're every time a real Ethereum miner mines a real Ethereum block, we just tack it onto the end, and suddenly we're running all of Ethereum inside of Bitcoin script inside one single UTXO. And so then all of the real Ethereum miners could just start mining on the simulated version of Ethereum and stop running the original, because, well, the Bitcoin miners are validating that their particular script, which checks their consensus rules, is correct. And then you can do all of your Ethereum contracts inside of Bitcoin script. It's just a matter of getting that first locking script right that checks the consensus rules. And then I guess if they do an upgrade because they want to change their protocol, we have to give a special escape constraint, which says that if Vitalik Buterin puts in a certain signs a certain key or something, then you can rewrite the entire thing from scratch, like they did in 2013 with the DAO thing. But but yeah, the point is, like, once that happens, and it will happen, it will happen.
And is it worth it?
Visualize. I don't know. I think it's going to be cheaper to do it this way in terms of
it's cheaper when you don't count what you just said, which is every time they change it, they add an opcode, or they roll it back or something.
Right. I mean, I guess you'd have to just stop and then create a whole new UTXO and, reinstantiate your network. So, then you'd be having a script with the new things. But I don't know. It's certainly, it's an interesting. I don't know. I just thought of that a couple days ago and wrote it on my board. I was like, well, what if one block in Ethereum was one state advancement of a stateful UTXO? Like you could actually start to build blocks on it and actually start to model what is the, and then you could run the whole real Ethereum network through it. It's just a matter of getting those rules right. And the problem is that they keep changing. So you could do it and then you'd have to redo it every time they want to do a new thing. But
Yeah,
I think eventually
Bitcoin
they'd
is
stop.
Turing complete. So yeah.
Right.
Absolutely.
I mean, eventually I think what would happen is they would eventually stop making new things because they would realize that we could just do everything on Bitcoin instead, and Ethereum would kind of just be this legacy thing, like, I don't know, X.25, I think it's called.
It would be a Rube Goldberg blockchain at that point.
Yeah, or I think it's SGML before HTML or a competitor to HTML or something, where it's just a thing that exists that like some people know about because they have to know about it because it's old, like COBOL or something. Like there's still COBOL programmers, but really, is it something that when I start building a new application, am I going to sit down and say, I think I'm going to use X.25, XGML, and somehow code it up that uses a COBOL server in the backend? Absolutely not, because there's better ways of doing it, and those better ways might include Bitcoin and not storing the entire state in one single UTXO like Ethereum forces everybody to do. So I think that might be a future in which, a future universe in which Ethereum gets kind of simulated and subsumed or brought under the umbrella of something that runs on top of Bitcoin, but we shall see.
Way back in the day on.
Oh, sorry.
Way back, I'll be really quick. Way back in the day on the sCrypt, I don't know if you could see it because the freemium thing, you can't go back anymore, but I was talking about a similar idea where it's just like you can run the original version of Mac OS on a web browser now, and you never want to do anything, using the software. It's kind of, because it's so slow, but it's kind of fun to go back and see what it was. But yeah, at this point, I don't think Ethereum is useful really at all, other than it has all these developers that are using it. But I don't even know how many of them are really using it now. It's just more of a speculative investment and misunderstandings.
There's
I
a
wanted
legacy.
to ask actually.
Sorry, go ahead.
Yeah, I wanted to ask because I was discussing this with a couple of colleagues before. What kind of experience have you had with people, that have been writing smart contracts in Solidity and they've had to, use sCrypt instead? So, what I was sort of debating is, is it worth trying to fit the, Ethereum mindset with Solidity into sCrypt, or would it be, a better idea to just start from scratch with like a sort of Bitcoin script mindset? And I was wondering what kind of experience you guys had with, using sCrypt and if you've had any like Solidity experiences or yeah.
For myself, I'm interested in just using purely Bitcoin script or sCrypt. I'm not interested in having Ethereum and then as a port whatever. But I have discussed it because there's so many people that are supposedly using it. But in my experience, there's really no projects that are like, I don't know. They're not. They should just start over on the new system. I don't see why they would try and do a port. But if there's something like, if these NFT things are really valuable to people, I guess you could have like a collectible thing in this little macro, in this little ported version. But no, most of the people that I interact, and the only way I interact with people really is people email me or they comment on my videos because they watch my YouTube. And I never really intended to be known as the Ethereum guy. I just studied Solidity and I wanted to do a video. And then suddenly I became like the spokesperson for it. And I was like, oh shit. And it's super overwhelming and I didn't want to be. But but yeah, so, but I just, you know, the people are just, usually they're not developers. They're like a business guy that has this idea for something and they raised a bunch of money and now they're trying to hire me to be a developer. Can you do this for me? I have money. It's like, dude, you are just like, you probably should have understood what you're doing before you raised all that money. And so now I think there's a lot of people with misincentives where they have all this promises they've made and they can't even, you know, they can't even admit that they're on the wrong path. So that's my
have any of you, have any of you guys done the BSV Academy?
Go
I was just going to jump in because I was going to recommend, I had done the free course Introduction to Bitcoin Development. And within that, one of the sections is actually kind of taking the concepts from Solidity and those developers and kind of tying it back to kind of the BSV side. So I would recommend if you go to the BSV Academy, it's a free course, and they actually do some demos and kind of test scripts and things like that. It's really informative. So
yeah, and one of the things too is that like there's a lot of misunderstandings about what blockchains were really about. You know, people. So it's and the account-based model and the UTXO model are very different, and so it's a lot. I don't think using the metaphor of Solidity is a good strategy. Well, I mean, it is to catch people's attention because it caught my attention to get interested in sCrypt. But at the end of the day, you need to really, like what I said before, Zen mind, beginner's mind. It's like a spirituality term where you need to like have like a lobotomy, like a clean slate, and look at it with fresh eyes. Because it's just, you know, people just had a lot of misunderstandings and anyways.
Yeah, I guess you know, maybe we can see what Xiaowei thinks, because I know in the early days of sCrypt, it was sort of modeled around Solidity, and sort of that was the initial plans for that. And I wanted to see, you know, developing over time, if that's you know, been a good you know, good thing or not, because yeah. So the last time I've touched any Solidity has been like around 3 years ago. So I don't know. You know, right now I don't have the best idea, but just looking at bitcoinscript, I know there's a lot of things that are different from Ethereum's, you know, opcodes, and you know they've got a bunch of different things in smart contracts themselves. So smart contracts are themselves like you know, an address, and you know, different smart contracts can call each other, and it's just like a different mindset. And you know, just discussing with some colleagues, and some people were, you know, saying that maybe it's a better idea to just you know, start from scratch with bitcoinscript instead of trying to, you know, model it into Solidity. And I don't know, yeah, did you guys have any sort of success from people coming over from Solidity to sCrypt? Because if that is the case, then you know, that is a pro for doing it that way.
yeah, one thing I would recommend you checking out, there's actually a podcast episode that goes pretty in depth with one of the lead developers of Crypto Fights, which is actually at this point the most successful use case on BSV. And he actually was originally on Ethereum and using the Engine Layer 2 network. And he studied BSV, and kind of in the episode, he explains exactly why the opcodes are a lot more advantageous, and some of the issues he was running into with Solidity. So I think I can, I think I should be able to pull that up. I'll link that in the chat, but I would recommend you checking out that episode. He does a great job explaining the differences in a technical way. I think you might want to check that out. So
yeah,
Actually,
thanks. I have spoken to him a little bit, but I think so the stuff that they're doing with Crypto Fights is a little bit different. It's like some layer 2. So it's a little bit different from actually writing smart contracts, if I'm not mistaken. Yeah. So do you know?
Yeah, you're one step ahead then. So
do you know of anyone who actually, you know, was doing some smart contract in Solidity that wanted to port it over or do something similar in sCrypt, or maybe, you know, because on Solidity they have like you know, standard contracts like the ERC20 or ERC72 or whatever the NFT one was called, or something like that. not sure if you guys have done something similar with sCrypt.
The goal of this is to make it easy for smart contracts or programs that's been built on Solidity to move into the sCrypt or into BSV. Is that the goal? Because I'm actually my history is actually machine coding, and I read opcodes. And I was actually going to ask Jiawei if when you run like sCrypt contracts and when you deploy it, does that convert into the opcodes, like the script opcodes? If that's the case, then we could probably create a like a dictionary where you can see one-to-one versus how the Solidity contracts convert to the opcodes, and then how the sCrypt, and then just do a comparison and see if there's a way to convert those. I don't know, just the thought process that I was thinking. But I would, I actually love to go through the opcodes, because that's more because I do low level programming rather than high level programming. So yeah, that would be really cool to build on.
To answer your first question, does this gets translated to low level like opcode, which people usually call script? Yeah, definitely, because for a Bitcoin node, right, the mining nodes, they don't understand sCrypt. So sCrypt is just like think about it's like a syntactic sugar. You definitely be converted because no miner understand this. So yes, the answer is. So for the second thing, I think, okay, I always want to do it before I just talk about it. So let me show you something. I think it's cool. It's not public yet, so it's just for you guys to, because you jump on the data stream. So internally, one way we're doing is we're trying to have some kind of like a tool. Usually people call it transpiler. So basically, you can think of this is for example, right? This is the most famous, I would say, Solidity contract, ERC20. For people who have not seen this, is like all the fungible tokens, mostly they're based on this, right? So you can see this. Let me put on side by side actually, so you can see what's the result would be look like once we have this transpiler. So close this. Let me put it on side by side, so it's much easier.
Woo-hoo-hoo.
Okay, so you can see that this is in Solidity, right? Let me it's all this annoying S. Can you see here?
Yeah.
So this is this is the sCrypt version. You can think of. I mean, it's up to you guys to see how similar, at least visually, this is. But underlying is doing completely different things. But even just from the appearance, it kind of looks similar, right? This is like a rewrite of ERC20. This is Solidity. This is sCrypt. Here's the thing. So this for now, I manually write this. Okay, but we are working on a tool basically called transpiler that can automate this. So that will hopefully makes even some people who have already spent most of the time, or even off time, or even spend like millions of dollars to build the apps, right? Contract in Solidity. I'm going to then to say, hey, if you want to migrate here, you get 1,000 or even 10,000 times cheaper gas fee, but you also have tools that can help you migrate. You don't have to rewrite from scratch.
Xiaowei, but the underlying protocol is absolutely different, right? So what it does, what Solidity does here to get the output versus what sCrypt does here is absolutely different because of the fundamentals are different.
Yeah, here's the thing, right? The programmers don't have to know, right? Do you see what I mean? It's the same thing with the compiler, sCrypt in the beginning, right? You don't have to know the lower level stuff because it's not the most efficient way to develop programs. I mean, you can write everything maybe in some kind of assembly code, right? You can do it, but usually that's not a good idea. especially for modern developers. Try to talk to any like a JavaScript developer. Hey, you can learn Force-like language so you can program on Bitcoin. Is it may be for a good choice for you, right? Because you're like a high level, but anything that's got a little bit convoluted, like complicated, is people will be like, no, that's too much.
No, what I meant to say is like on the because on the protocol level, like what because you can't really move from account based to the UTXO just by moving the changing.
Actually, you can. A lot of times you can. That's what I'm saying. Yeah, I mean, in the most extreme case, right? I think Tai also briefly mentioned this. You can think about the whole Ethereum in one UTXO, right? That's a state, right? And then you just keep propagating the state. This is just a state machine, right? So even in that sense, you can see why the Ethereum model does not scale well, because every change you have to change to the previous UTXO, right?
Mm-hmm.
You cannot do it in parallel. So that's another way to visualize it. Mm-hmm. So you can simulate the short answer.
Okay.
Cool.
That's cool.
Yeah, I mean, the thing I think, and what Samir was talking about is because like I think we had this discussion on I could find which one it was. I don't know the exact date, but I was very confused about, well, where's the address of the previous transaction? Because when you read like the blockchain explorers for Ethereum, you just you have like an address with a balance, but then with when the UTXO model, you're like passing on these you're passing on like this as the state changes. It's there's no real just like fixed address for it. And so it is kind of interesting to like how exactly will it translate one-to-one. I think this, and it's great, people are gonna love it, but for me, I'm more interested in really understanding the fundamentals of just BSV, and then building native to BSV. And then last thing, okay, so with Apple, they do all this low level stuff, and then you sign like this license that you agree that you're not going to do all this illegal stuff, and then they give you like this really nice sandbox with all these APIs and all this like this thing. So right now in the Ethereum space, there's all sorts of scams and all sorts of crazy stuff, and I have kind of purposely like not been trying to attract a bunch of those people, because I don't want to like piss off Greg that all these people are flooding in and like doing illegal stuff. So one of the things that might be interesting is if you do build some sort of simulator, they have to actually sign up, kind of like I sign up with the App Store developer program. I get a license, and when I'm using all these higher level APIs, they really have the power to pull me if I'm doing stuff that's illegal. So because we don't want a bunch of illegal stuff to happen on BSV. So anyways, that was another thought that I had about that, if you really want to attract a bunch of Ethereum developers.
I mean, it's permissionless like protocol or whatever, so I guess people could do what they want, right? They don't have to. Yeah, don't be don't be afraid of what like crazy and I think or whatever. But yeah, I mean this looks really cool, Xiaowei.
Okay, cool.
I'd love to see what actual Ethereum developers think. I'm guessing from your answer, we haven't had that many people actually using this stuff much, but it would be really interesting to see what Solidity developers think. I mean, yeah, I'm sure you guys also get LinkedIn like messages, especially now in the bull market. We've got this new Solidity company. We need Solidity engineers, and
yeah, all the time.
Yeah, so
it's really annoying.
Yeah. So yeah, what I was trying to say earlier is like this is more of somebody who is programming Solidity will be able to easily start programming the sCrypt, but I think probably if they already start programming sCrypt, they will know the fundamentals of the they will have already converted from the fundamentals of the understanding the fundamentals from how Ethereum works and versus how BSV works, and probably they'll code in a way that aligns with the BSV protocol. I think that's probably that's the understanding, I guess. But yeah, this is really cool. Where we can onboard people who have been coding in Solidity just to be able to start like coding in a script. This is really cool.
I see this as a way to onboard a company who's got legacy code.
Yes.
And they want to relaunch their NFTs or relaunch their whatever business that was built on Ethereum, just relaunch it on BSV. And then they know that they can find the Solidity coders, and they don't have to worry about, oh, where am I going to find a BSV coder? I've never heard of a BSV coder or a BSV engineer. So that this makes me too nervous. So now I know I won't have to worry about finding engineers, maybe.
Yeah, I agree with you, Samir, on the last point that you said. Yeah, I think people who are, haven't spent much time on Solidity and are coming in fresh to like Bitcoin SV, obviously, and they want to write smart contract. I think it'd be more efficient if they tailor their sort of thought process to the way Bitcoin works, and maybe they do things. Maybe they use like meta opcodes or some stuff like that. But yeah, maybe not trying to shoehorn things into the Ethereum way of doing things. I think that would be more efficient. But yeah, as Bill says as well, for people who want to port things over, it's just, I think, very valuable. Yeah. So cool, good stuff. Shall we? Looking good.
Okay, man. So short answer, yes, is if you really want to get somebody into the smart contract building on Bitcoin, they don't necessarily have to go through the Ethereum like a step. So it's almost like now you want to train somebody to build some kind of application, right? Web app. They can probably go directly to JavaScript without going through like ASP, JSP, or PHP. This is legacy, web technology. That's just my opinion. Because for me, you also asked about, you have been in sCrypt for a long time. So at the very beginning, we also said syntactically, we want to make it similar, like a mainstream language. For example, Solidity or JavaScript. But here's the thing, right? I guess Samir mentioned. So even though the underlying computing model is completely different, here's the thing, for us, we are developing developer tools. So we want to shield all this developer from all these complexities, because somebody can just wrap around it using some high level tools. So it's like we're using Zoom, right? So we probably don't worry about TCP, IP, handshake, three-way handshake, whatever. So you can, but if just one guy have a very good tool, so nobody has to worry about these details. They don't, because for you, right? For example, for when you're coding sCrypt, you better not worry about the script side of things, or even say, how this contract get propagated or whatnot. We want to make sure it's almost if they are programming, let's say in some kind of JavaScript. So, and here's the positive news, right? Because for most of the people who are using, if not all, the sCrypt contract to build applications, for example, token swap, or let's say some kind of token systems, let's Fabric or Batch Wallet, most of them have Ethereum background, but they seems to be okay when they're migrating. It's a different mindset, but I think if you can code in Solidity or even JavaScript, you should have no problem coding sCrypt.
Yeah, and one of the things is if you really do think of it like as like another kind of higher level development environment that you're creating, because like they say, oh, you can change the protocol. Well, guess what? Apple changes the protocol on me for all sorts of things, how different user interface develop, or how different user interface elements are coded, how you interact with them. Every year when they release the new operating system, they change a bunch of stuff. So maybe you could have some of these, like, if people do want to, and maybe not, I don't know, but if you think of it as like you're developing this sandbox for higher level developers, You know what I mean? And there could be many of them. It doesn't, like Ethereum was really easy for me to pick up. I just read it. I'm like, oh, I get it. It's like object oriented, blah, 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 blah. sCrypt has been a lot slower for me to pick up because I have to understand the UTXO model. And I think I also just having the idea of Ethereum and Solidity got in my way because I was trying to fit it in a round peg in a square hole instead of just seeing sCrypt for what it is. But if you have these higher level development environments, then these people can develop on that and they never, ever, ever have to worry about these lower levels. But they can if they want to. But that's what I'm also saying though, is like there may be, whoever's issuing these higher level environments may want to have some sort of licensing, but maybe not. I mean, I don't know, whatever, but that's just a thought.
Yeah. So when somebody codes in Solidity, I mean, the only thing, the way I like you mentioned, Kevin. So when you picked up Ethereum versus when you were trying to study or trying to read through the sCrypt, it was difficult because not because of the syntax or the code, it's because the fundamental protocol is absolutely different. So I think
Yes.
So when we build things like this where we allow Solidity's programs to start working on the Bitcoin, that was my question, do we incorporate those protocol changes as well, or just the programming idea? Do we incorporate the lower level or the higher level? So that's what I was basically trying to question. I don't know if it makes sense, Jawai, but so when so the fundamental protocol difference, right? The account model, UTXO model. So if you build something, if I'm used to understanding the account model, my programming is going to be exactly based on those protocols. So as soon as I start moving my code into the sCrypt, and I build in the similar mindset, does that automatically convert to a UTXO model? So, or do I have to, do I have to understand the UTXO model, and when I start coding, that's when things start building. So that was kind of like my question, but I think I think I think you basically answered my.
From my understanding, and this will go with what you're saying, Spirit, and correct me if I'm wrong, but you can have an account-based model type of system inside a UTXO model.
Yes.
But you can't do the reverse. So you can't have a UTXO system inside an account-based model. So
I don't know.
Maybe.
Okay.
It would really suck. But technically speaking,
well, okay. Technically, well, okay. Here's another.
Economically, no.
Can you run a program that's coded for 64-bit process, or 64 bits on a 32-bit chip?
Yes, because you could emulate it, I think, because a 32-bit chip is still Turing complete. But it would really suck. Yes. But yeah, I totally see what you're saying. I was just kind of,
Okay, so for simplicity's sake, you would totally fry the computer. You'd have to slow everything down, the lag time. It wouldn't work, okay? So, but for simplicity's sake, let's just assume what I said was true. You can have an account-based model within a UTXO model, but you cannot have a UTXO model and account model. And so, you can have this Ethereum account-based model thinking inside of inside of, and I think that maybe is what Joe is talking about here.
So when they deploy, regardless of how they code, they can have a account-based model when they code, but when it deploys to Bitcoin, the Bitcoin SV at the lower level, it should be able to convert to an account-based model, and it should be seamless. So that's how it makes it inclusive for people to just still be able to work on an account-based model in the real life, but then when the protocol is mining their transactions or whatever it may be, it's a UTXO model. Or is that the goal here, or is that you can't, account-based model doesn't even work in real life? We should all move to a UTXO model because it's more efficient, it's more. So that's kind of like my understanding, so is it more of a complete conversion because it's so efficient and it works, or should the developers be still okay to think from account-based model, but when it deploys to the protocol level, it all works in the UTXO model. That's why it's efficient. So that's kind of like I don't know, my thought process.
the way that I see it is, it's like I keep on using the metaphor of like different types of governments. It's like little hoopy dolls. So even though it's going to be less efficient, if you just have it for small things, then it's fine. It's like, so if you look at the United States government, we have like the federal laws, but then each state has their own laws and each city has their own laws. And it's kind of how I view this. You have BSV or the UTXO models, this base layer, but then you could have these like little, I guess, states or counties, whatever you want to say, that have their own kind of system, but it's dependent on the federal laws. Like it's there. And so one of the metaphors I always use in the sCrypt Slack was, like you can have a hippie commune in a capitalist society, and you see, but you can't do the reverse, right? So you can't have New York City or wherever in a hippie commune, but so it's like, the hippie commune doesn't scale because we're not keeping track of who owes who's what, et cetera, et cetera. We're not going to use money, man, like whatever. We're going to grow all our own food. And so that doesn't scale, but it does fit within a capitalist society, because we'll just cut you an acre over there and you could just be there and somebody's taking care of you as your, landowner.
Yeah.
So that's
yeah,
one way of looking at it.
Yeah, and somebody may be okay to just build an account-based model in UTXO, but over time, I think they're going to realize that, yeah, UTXO model is better. So I got to skip this whole thing that I built on top of this and just go directly. So that
if you want to
potentially
scale,
might happen.
If you want to scale,
yeah, that might happen in the future. But right now, with so many things, so many things already built on Ethereum, and it would be maybe better, or in terms of our time scale kind of thing, like it would be better if there is a way just to understand the account-based model and then put it into UTXO, so that the transition is down the line is much easier for even the mindset as well. I don't know, just my thought process, because people have to rebuild with even that have already been built in Ethereum. They have to rebuild towards sCrypt. So there's both path. I think that'll be cool. So but so you're gonna say, Trevor?
It's exactly what concur with what you just said, right? So for us, we have two types of newcomers coming. The first one with no let's say smart contract blockchain programming experience at all. For these people, they don't have to go through all this. I wish I would call it like a legacy, like a smart contracts, like a Solidity, or let's say Tron or Solana, whatever, right? They have no problem actually. So our first-hand experience, because we know some companies, they are building sCrypt build-based products. They just get some like a fresh like a college, student, graduate, new grads. They just ask them to learn sCrypt, and then they can, I think usually within a week or so, they can get a very good grasp, and then they can develop apps on top of it. One example I mentioned is MetaID. So we have been working with them. So they just have some new developers. They have no even blockchain experience. So for these people, they're not entrenching or like altcoins. They can just directly go to sCrypt, Bitcoin smart contract without difficulty. So the second thing is,
I would also just add, that's what I would want to focus on more, because there's people, because that's just so much easier. But people have been not pressuring, but asking, how do we get more Ethereum developers? How do we do this? How do we translate it? It's like, dude, I just don't want to deal with them. I just don't. I know my YouTube video has it, or my YouTube channel has a video, but just disassociate me from it. So,
but from a very high level, if we want to, when we talk about scaling Bitcoin, it's the way I think it is, it's to be inclusive of everyone.
Yes.
Scaling is just not be able to.
Yeah, that's what I said, right? It's one. There are two types of newcomers. One is who have no background in blockchain or smart contract at all. The second one, the people who have already invested a lot, right? Either time or efforts or even money into the ecosystem. For them, we also want to be inclusive of them, right? We're not saying, oh, you are not passing the purity test of BSV maximum list, right? You have to say you are loyal to BSV or whatnot, right? So we are not saying anything. So for those people, we also have the language, the tools, and also all the SDK, the tool sets for them to easily migrate if they ever want to, right? So it's kind of we do two things at the same time, actually. It's not a, a dichotomy, right?
Yeah, and I think when for those, the second type of people, it's important that we let them be who they are with their account, the understanding of the account-based model, but then the hard work is being done in that layer where we move it to the UTXO, because the fundamental is works better with the UTXO model. And we're just giving UTXO model as one of the examples, but there's so many other things like within the protocol, the difference between the protocol in Ethereum and UTXO. So I think for us, it's important to understand both sides and be able to provide that efficiency or transition. So I think that's
agree.
Yeah.
Agree. So that's probably give us a very good time to jump to the second item where I want to talk about. It's like because Samir and a bunch of other people have been asking, right? So what's the difference between if put something on chain, running some code on chain versus something off chain, right? Because it seems let's go to some of the basics. I think the next article, I think is a very good example of showing case what smart contracts are good for and when do you want to use it, because probably, and also we can kind of extend this topic, right? What's the difference between account model and UTXO model? But anyway, so first let's briefly go over this, what this contract is, and then we can expand on more how this shows the difference, the different approaches of philosophy between account model and UTXO model, I would say. So for this, so you guys probably heard about this concept called a vanity address, right? So basically when you generate the Bitcoin address, some people, they want to have some kind of a pattern, readable pattern. For example, you want to put your first name or anything, you can just keep generating private keys until you hit some pattern, right? Then that's what is stored. It's similar to kind of like a hashing, but it's just doing SHA-256. You just, for example, you can increment private key until you hit some known pattern you want to have. For example, here, because this is joint work between n-chain, so they have this example. They want to find a good validity pattern that's contained the n-chain prefix. So that's how it gets started. So there are two ways to do it, right? One way is, as we have shown before, it's called something called zero knowledge proof. So what it does here, right? So for example, you go all the way through here. So this is one way to do it. So basically you put most of the work off chain. You only put the very small part, which is basically the hash puzzle. If you can find some pre-image, the hash to a given value, then you're actually producing, you are very sure. Once you pass the zero knowledge proof, you can know this prefix is what you want. And then through the smart contract, you have automatic exchange, right? The atomic exchange. You pay, you get the secret. So that's the number one reason for, in my mind, at least, for smart contract to exist, right? Because whenever you do commerce online, right? Not physically in the same place, especially now because of COVID, a lot of things, more and more things are moving online, and you are not in the same physical space with the person, but you also want to conduct business with the person. How do you do it? If you have Alice and Bob, Alice want to purchase some goods or service from Bob. So you always have the counterparty risk problem, right? For example, if Alice pays Bob first, but may not deliver the goods, vice versa, right? If Bob delivers the goods, the Alice may not pay him, right? So that's the part which, to me, I think the number one reason benefit to do this kind of transaction in contract, because it's atomic, right? Either both go through, the transaction gets mined, both Alice get the goods and Bob get the payment, right? Or if the transaction is invalid, it's not included, mined on chain, it's rejected. So either it happens both direction or it happens in zero direction. You don't want to have one side direct, only you succeed in one direction, right? Then it's not a fair exchange. So the extending one example here is, so I don't want to, probably not a good idea to go through all the detail, but here, once you put most of the computation off chain, not in a smart contract, so that's a severe problem here. So here you can think of Alice is buying a validity address from Bob, right? Because to generate it, you have to keep the machine running for a while. And I may not have the machine. I don't know how to code it. I want to pay somebody who can just give me this pattern from here. So one way to do it is using something like a computation off-chain to prove this is the valid secret. And then you construct a smart contract, like a hash pattern, right? But the problem is, in some step, right? Once Bob has proved to Alice, I know this secret, Alice can walk away, right? In this case, Bob spent a lot of energy computing this, maybe 10 seconds or even 10 minutes, depends on how complex the pattern is, right? But then Alice can simply walk out. In this case, Alice, Bob is almost like a cheated, right? Because he spent a lot of energy and then Alice just walk away. So we have another way to do it, but by putting all the logic, because when you put a computation off chain, you always have the risk. If you're not careful, you have the counterparty risk because the other party can just walk away, abort, right? Or cheat in some other way. But the benefit of putting everything on chain, which we did in this article, basically it does achieve the same problem. You want to outsource some kind of validity address. You want to buy some validity address of your pattern. How do you do it? You put everything on chain. So basically, the short story is somebody has to give you this secret X, and this X, once is combined with your own, this X basically can generate this validity pattern. So if you put everything check into the smart contract, then Bob Alice cannot walk out, right? Because if Bob had the correct X, he can take the money. It doesn't matter whether Alice is happy or not, right? This is everything that's on chain. It verifies. I think somebody is in the Slack channel, they already run something. I don't know, I haven't checked, but they're posting some kind of like a bounty. They want to have some first name prefix the validity address. So that's the first point I want to make. Basically, by putting things on chain, basically on chain smart contract, you avoid the counterparty risk, right? Does that make sense, Samir?
That's a good one.
Yep. Yep. It does. Yep.
Yeah. And the second thing I want to extend on our first discussion. What's the difference between account model and UTXO model? Because UTXO model we know is the predicate system. So I could be wrong, but I'm probably not going to put all the computation in the world into the Bitcoin blockchain, even maybe like 100 years later, because it probably doesn't make much sense. If I want to, let's say I want to view some pictures just on my phone, right? Internally it's doing some kind of calculation, of course, right? But you may be able to do it, but I just don't think all the computation is going to migrate on chain. And that's why I think just my guess why the Satoshi designed this to be a predicate system is you can think about this as a proof system. The Bitcoin smart contract is a proof system. So somebody is always, in the unlocking script, you have to show some secret that the locking script just check whether this is true or not. You don't need to verify this. It never actually compute. You just verify the computation is done right, correctly, like what we see here, right? That's another difference. I think Ethereum, why is an account model? Because you think about it's doing computation, right? I think one of the reasons is called them the global, world computer, whatever that means. It's trying to compute things. But Bitcoin model is, yes, we are saying we don't have to compute everything on chain. It's like Craig has been saying forever, right? It doesn't make much sense. If you compute this number, the supercomputer take you like 10 minutes or 10 hours. You spin up like 100 machine instances. So for Bitcoin, you only have to know whether you get the right result, right? If you get the right result, you get paid. So I think that's a fundamental. You can also think about philosophical difference because the account is almost module, the on-chain computation. You are going to pretty much duplicate all the computation in the world, put it on chain. And that doesn't make sense to me because Bitcoin model seems more reasonable because I don't have to know whatever you do off chain. I only want to make sure this result is correct. If it's correct, why do I have to, rewrite? It just doesn't make sense, right?
Yeah, I think I understand the UTXO and account-based model in a way, just like you mentioned, but in a way such that, like, so there is a smart contract or even a UTXO that's on chain, but it's not constantly checking for the unlocking script. It's just there, and then whenever it finds the unlocking script that unlocks it, then it spends it. So versus an account model, in like there's constant check of whether there is a new unlocking script or not. There's constant check, and that's what makes its computation heavy. And it's not really necessary. It doesn't mean that the smart contract, and every state change, you don't need to check the the UTXO whether it needs to be spent or not. We just wait until the solution is found, and that's when it spends it. I think that makes it so efficient, the UTXO model, and versus the account model. And I'm actually working on an asynchronous messaging system. So like, whenever I send some messages, right? So to somebody, they automatically receive the notification saying, oh, this guy has sent me a message. It asks for an action, a reaction kind of thing. But the asynchronous messaging would be like, I send a message and it stays there for whenever it may be, and then as soon as there's the reaction from the other side independently, which is like an unlocking script, that's when they're able to see the message. It's not like a notification, so that makes it more efficient. So I don't know if there's a real use case for this one, but I'm thinking, I'm actually working on a design which basically works on a kind of like a UTXO model versus like an account-based model, and this is more of a again, philosophical way of thinking. But yeah, I mean, there is no question UTXO model is much more efficient when it comes to like computation and building smart contracts or any kind of like apps or whatever. So yeah, this is really cool, Xiaowei, for how you explained it.
Any other guys want to pile on it?
Yeah, no, this is very powerful.
Okay.
Yeah, appreciate that.
No problem.
One of the things, Shamir, you were discussing with regard to this chat design that you talked about is the development of this as within the framework of the UTXO model, and so it's pertinent to ironically to one of the things I was talking about also in the past, which is how do we do a UTXO based chat? So I think I was talking to Jerry Chan, and basically the idea we came up with is this talking stick almost, where you have a UTXO which represents not the individual message in a conversation, but the token that gets spent forward is the conversation itself. And then the locking script of the current rendition of the state of the token stipulates the current members of the group chat. And each of them has a public key or a way to sign and unlock. And so what they do is they unlock the locking script, they push their message onto the token, and then they lock it back up, because the token kind of enforces its state propagations that it needs to be locked up again every time. And they stipulate, here's the people who can respond. And so if we want to remove somebody from the group, then you would remove the public key of that person. And so essentially every member of the group has the right to spend forward the UTXO by one increment by adding their message to the conversation. And at the end, if everybody's done with the conversation, maybe it was a negotiation, maybe it involved money because you can put money into this UTXO and then take it back out. So maybe it was like acting as an escrow or an agent between two parties who are acting to form a contract. You can express constraints by which, okay, well, when this certain message gets posted, then the amount of money in the contract needs to increase or decrease or be paid out to a particular party, etc. So UTXO-based messaging that involves custom sort of constraint stipulations that you can use to create and enforce many types of stateful contracts and things, or something that I think just kind of rang a bell with what you were talking about, where we can use a UTXO to have a asynchronous chat system that can do all the Bitcoin-y stuff as well.
Yeah, definitely. Yeah.
That's cool. Another, I was gonna say though, before Ty said that, is that I was also, you were saying any reaction, and I know I've said it before, but I'm gonna say it again. You might hate me for it, but I really dislike smart contract is the term because it's really confusing. But if you use the idea of programmable money, then it actually makes a ton more sense because you understand that, oh, I could get this money under these conditions. It's like there's a locking script, and oh, I just have to unlock it with the unlocking script. It's money that's programmable, so you can put different things on it. But the term smart contract, it's like, well, you know, who's contracting? Anyways, that's. But I'm just gonna start. Well, once I don't have a priority to do more videos, but I'm working. I will do it eventually. But from now on, I've like months ago, I said I'm never using the term smart contract again because it just confuses the heck out of people. So I think programmable money it's like, oh, I get it.
It does seem more clear in my opinion as well.
Yeah. Because who's the judge? Who's going to fulfill the judge? I mean, I know that you say the miners, but
the miners are the police, they're not the judge. The judge is the judge in a real court.
Exactly. Yeah, they're the enforcer. The miners enforce it. And
the court orders
so
the police to take. Yeah, I see what you're saying.
Yeah, you don't want the executive branch or the enforcers to be making the rules at the same time. That's no bueno. That's like kind of what we had in COVID with the emergency orders. It's like now we get to make the rules without going through the Congress and the Senate, and that's disaster, man.
Are you sure you don't want the executive making the rules? I mean, don't you think that Gulag Archipelago was a really great illustration of, you know, all of the possibilities, the amazing things that could happen if we let the executive branch make all the rules? I mean, nobody sold on that. Nobody.
Marco Caro.
Yeah, no, Kevin, like you mentioned, it. You know, the way I look at it is the blockchain automates the enforcement of those, you know, conditions-based, contracts. And I agree, the smart contracts is definitely a buzzword that's, you know, well past its prime at this point.
Yeah, it's just confusing to people, but so that's one thing I just want to add. Programmable money, it's like, oh, so I can have this dollar that I can write conditions on whether you get to spend it or not. Well, it's not even that you spend it, that you get to get it. I was trying to draw out this whole, and this is why I'm still working on it. I'm going to do it eventually, but I was like trying to do an introduction to BSV, and I like had all these little like these little safes with money in it. And if you want to get into it, you have to unlock it with a locking script or an unlocking script. So it has a locking script on it, you have to unlock it. And it's just, you write programs to control the flow of your money or your BSV in this case.
Yeah, I like that. We went through like a bit of a refactor with our Bitcoin libraries to change, because everything used to be like a script pub key and a script sig. Legacy
those
stuff.
Terms.
Yeah, so we went through like, you know, with our version 2 of our, you know, Go Bitcoin transaction library, we renamed it to, you know, locking script and then unlocking script.
Same for sCrypt and SDKs. Yes.
Yeah. It was just one thing which was a little bit controversial, because you can have, so, you know, on a UTXO level, you have it's locked, and then you unlock the, you know, the unspent transaction output. But then on a transaction level, you know, we went back and forth on this a little bit, but you know, that then you would have, because you know, with with legacy transactions, we have this concept of a unsigned transaction, and that means, you know, the inputs don't have unlocking scripts on there. And then if you want to, you know, make it in a general form, not just specific to script pubkey and script sigs, it wouldn't be unsigned, it would be not unlocked. So it's like a double negative in there. It was really shitty with the code. So we kind of I think we went for, at one point we had like, you know, locked TX, and then that was, you know, a bit ambiguous because there's overlap with nlock time. The transaction is locked with nlock time, and I think the conclusion is we went for unsigned off. So the transaction isn't signed off. So you sign off a specific, you sign off the whole transaction, and that kind of keeps us in between, backwards compatible with like, unsigned transaction, and avoids us having this double negative of not unlocked. Yeah, I want to see what you guys thought.
That's really good. We had this whole discussion about SigHash because I was trying to understand what, and I think that's what you talked about. You could have something that's there without a lock-in script or something. So yeah, there's this whole other issue of signing. Yeah, so that's really nice. I'm gonna listen to that back and really try and make sense of what you said.
I was gonna bring up SigHash because we've been doing a bunch of stuff with SigHash flags, but has anyone been exploring that stuff?
I didn't understand it. I was just trying to ask about it. Like, what is this thing? And then you could have it so, yeah. So anyway, we did a whole episode on it.
Yeah, we did a whole episode on SigHash. Basically is engine, surprisingly, I think you maybe have not heard of it, but in sCrypt contract is like a regular thing. So that's why we even built into a standard library, because so many cases you want to use this SigHash. Because for example, right, a lot of time you want to have the contract stay the same, but even for the Satoshi's amount, right? It's a stateful contract. You want to keep propagating state, but you want to make sure, before the last step or whatever, you want to ensure that nobody can withdraw money from it, right? So the Satoshis remain amount. The amount remains the same, but then how do you cover the transaction fee there? So by that case, you always use anyone can pay. So you always do that thing, and so the contract stay the same, and you can always have one or multiple input or one input to cover you have one exchange output to cover the transaction fee. And also people, sometimes you want to only propagate the state, maybe as a first input and first output. So you always use a SigHash, anyone can pay plus SigHash single. So it's a lot of times
for anyone that wants to learn SigHash flags. I think the best place is the bitcoinsv wiki. So we did a bunch of work, mainly Wei at nChain. Wrote up a bunch of diagrams on the bitcoinsv wiki for what parts of the transaction get signed per different combinations of the SigHash flags. I think that's the best resource that is available on that if you want to learn.
Okay, I'm going to send in the group. Yeah, I found it. Okay. Oh, okay. Phil already got it.
Cool. Maybe Xiaowei, maybe that's a good segue for kind of the next topic. I think folks were asking about what's the benefit of an on-chain NFT, right? And then I think that leads into kind of the on-chain data and everything you can do with that. So I think that is very interesting.
Okay, so much. Okay, I'm a short answer. I think I can jumpstart this, get the ball rolling. But if it's not on chain, even is it like even NFT? Why not just stuck in like a MySQL database, right?
Yep, I look at it as if it's not on chain, it didn't happen, right?
Pretty much, yeah.
Record of history, yeah.
Yeah, maybe even yeah. So if you say, let's say some company, right? Let's say, I don't know, a company, right? They issue some NFTs to talk about the product, right? What if this goes out of business? Then they're not maintaining the the database anyway. Then your NFT is gone, right? Versus put it into some public blockchain. Even a company goes bust, as all the companies, right? So eventually, if it's in a long enough time horizon, everything goes bust. So your NFT is still good around, right? If you really want, pass it to the next generation or whatever. And companies usually die much faster. So you may even have.
Yeah, definitely. Yeah, and I think for me, just looking at all the chains out there, the holy grail of NFTs is absolutely the fact that it's on chain, and there's no other blockchain that can possibly do that. They all have some type of system to link back.
I see. I now get what you're saying. You are saying like, for example, something like a JPEG. Most other chains, maybe I haven't checked.
The fact
maybe
that
they're stuck in something like a Filecoin, or they're stuck in somewhere else. Right. They put a hash. I would say so. BSV is the only one you can put the original, the video or the picture on chain itself. Okay.
Yeah, that's profound. Yeah.
That's where I would kind of Well, I am slightly biased because I did build a storage provider that makes money by hosting things and contracting to do it on chain, but not actually putting things on chain. But I think as long as you have a hash on chain, as well as the record of obligation that people have made to hosting that hash. I mean, because if you think about it, if there's this giant PNG image or whatever, or even an MP4 video, like a miner doesn't need to keep that around in order to validate their scripts, unless you put it inside of a UTXO. If you put it inside of a UTXO, then they do have to keep it around, but not all miners have to even keep the entire UTXO set. That's a common.
Yeah,
So,
you don't have to keep it around.
Yeah, I'm glad we're bringing this up. Yeah, because this is part of what's fascinating with. And sorry to interject. I was just going to say, everything that Craig is talking about and MetaNet, right? This is kind of that end game vision of what they're looking at, and then if you contrast that with, for example, Cyto, they're trying to do something similar, and I can kind of get into why I think that's going to fail eventually. But keep going.
Yeah, like Ty is building, the Bridgeport, and that, so as long as any overlay networks, they can host like files or like anything as such, as long as they're following the protocol of the base layer, and then there is some way to provide a bridge between these. I think that's all it matters. Like the file, the photo itself doesn't need to be mined by a miner. I mean, they can, and because it's mined, it'll be available until they prune the data, until whenever, and that you could use the miners infrastructure itself to store these files, but we can build our own overlay networks in between, and just have the ability to provide a bridge between the base layer to whatever layers you're building right now. And there's a way to connect trustlessly or basically following the protocols of Bitcoin. I think that is enough. That's how I think. But at this point in time, yes, like some other chains, when they talk about NFT, there is no security from the base layer, regardless of whatever. There is no security from the base layer, and that doesn't. And that's really not an NFT. If there's no base layer security, just because it's in blockchain. If it's just a glorified database, like Chao is mentioning, you can put in a SQL database and call it an NFT, but you don't get the security of the protocol.
Sorry to interrupt. I need to drop off. But it was great. Okay. Great to meet everyone.
Oh, great. Yeah.
I'll try to drop in more often.
Oh, thank you so much.
Okay. Yeah. Join anytime. Okay.
All right, guys.
Nice to have you.
All right. Take care. Have a great day.
Have a good weekend.
Nice to meet you
too.
All right.
Take care.
Bye.
Good to see you, Jed.
Yeah. So what I was saying was, the way I look at it is in the future, everything is going to be on chain, all data essentially, and the miners, all they care about is the hashing part. Once that is done, they don't care. They're moving on to the next block, which is their job. So that's where it comes to those, overlay networks. And I understand MetaNet is basically going to build out a structure to kind of have edge nodes that can help store that. I don't know where exactly that is right now in terms of the roadmap. I don't think it's really a lot happening yet, but I kind of see the vision, right, where once that information is hashed by the miners, it's always on the blockchain forever. And then whoever's incentivized to host that is going to have, kind of a secondary node, a non-mining node, who can provide, content delivery, et cetera, right? And set up kind of their own business model to service that.
Well,
yeah,
sorry,
so that was something that I was, I've been thinking a little bit, should we have everything on chain first and have mined, from like not only hashing, but pretty much everything on chain, and have it mined. And then when it moves into enough blocks, down the road, then we build overlay networks on top of those mined blocks? Or should we have the overlay networks that basically, doesn't have all these files don't have to be mined, only a hash can be provided, and then and still get that security. So this is something that I've been debating. I don't know what you guys think, but I remember I was talking to Ty as well in one of if you call earlier about Bridgeport and how Bridgeport builds this middle layer, or like an overlay network. But what Ty's, I think Ty, correct me, but I'll let you speak. But do you build that overlay network before and just send the hash to the miners, or do you so I don't know, maybe you can answer how you're building that overlay network in between the miners and the users?
What's happening? Well, there's a couple things. The first thing I think is related to the on-chain storage stuff. Bridgeport is a framework for building overlay networks. One of the overlay networks that is built using Bridgeport is called Universal Hash Resolution Protocol, or UHRP, or the NanoStore protocol, which is all the same thing. It's a protocol by which people can pop up and say, I hereby commit to hosting this hash of this file at this URL for this length of time, signed by my reputation key. And so people who reliably host things at the place they say for how long they say are going to build up good reputation for hosting things reliably. And people are going to go to those people and say, hey, I will pay you $5 if you host this video for the next 50 years at this URL, and sign it with your reputation key that has also signed these other 50,000 other hosting contracts in the past. So that's how I think it's going to happen, where we have commitments. And so the question
you're saying you don't want to store everything on chain?
Not everything, the hashes. Remember I said the contract contains the hash, but I'll kind of get into that. But the first thing I would address there is, well, that's centralized because there's only one storage provider, but no, you can have multiple. So if you want the same video to be committed by 3 different reputation keys, then great, pay those 3 different entities to sign off on the same thing. And then you have 3 different people in 3 different regions around the world. And so you pay for as much assurance about your content as you want. But when you put something on chain in an op return or whatever, there's no single person that actually accepts a contract to keep it around. You're not contracting with anybody. Whereas with this, you're actually contracting with an entity who is making that data available. Because in an op return, okay, great, I have this image in an op return or even inside of a UTXO. And for the sake of simplicity, I'm just going to assert that not every miner has to keep around every UTXO. So if I make a 1 petabyte UTXO, a miner could just not keep it around. And then if some other miner wants to mine it, they could. But point is, for simplicity's sake, we can kind of omit that case because there are ways that it can be omitted. Putting the data directly on chain does not create a contractual obligation between the parties, the person who put it on chain, and any single other entity. I mean, you have to retain it. And so when I look at on-chain data, I see the Merkle root, and then I see all the transactions that are in that block. And in order to assert that a single transaction is on chain, I, as the asserter of that claim, must provide the Merkle proof to that transaction, as well as the transaction itself, so that I can say, hey, look, this is how this ties back into the block headers. And so if everybody in the entire world deleted a copy of a transaction, there is no way to prove that that transaction was on chain because it was deleted by everybody. And so in the same sense, this is why it's okay, I think, to put only the hash of a file on chain, because now I have this commitment contract by the storage provider that says I commit to hosting this hash on chain for this length of time, etc. If I want to prove that data existed at a certain time, which is the functional utility of having something be quote unquote on chain, what I would do is I would retain a copy of the commitment contract where that hash is put on chain. I would retain a copy of the Merkle proof associated with that commitment contract. So now I'm proving inclusion of the commitment transaction, which is 1 kilobyte or less. But then if I want to prove the existence of the data itself, I just provide the pre-image to the hash. So I just say, well, here's the data that hashes to what was committed. And now I've proven the same, I've attained the same functional benefit of having the data on chain in this particular case, but without having to have every miner keep it around and deal with all of the economic block propagation and other inefficiencies that relate to having that data available in that way. So that's my way of solving this. Is I don't see a reason.
Doesn't that and this is something that I'm still in two minds, but doesn't it spread the trust if because if we're not really mining mining any source of file and just publishing the hash, because it doesn't that spread the trust. We can always do, because the section 7 of the white paper says reclaiming the disk space, where you can once it's mined, and we can create business on top of the data that's been mined, and the miners no longer want to store it, then we can prune that, and then we can create all sorts of business. But now this is on top of the mined data, and it could be like the files or images, videos, and so forth, instead of just providing the hash. Yes, it's an overhead for the miners in the beginning to have the infrastructure for all these data in the beginning, but over time, I think the trust on the miners will be intact, and that's one way to look at it. But there's the other side as well, where there's an overhead to the miners, and we can just publish the hash that gets the enough security, and I can understand that as well. But I don't know, just debating right now what should be the right way.
Yeah, the vision I'm seeing is definitely it has to be on chain, and it's kind of a chicken or the egg problem, but eventually you're going to have services that are built around an entity or company who they will know beforehand which information is going to be uploaded on chain or hashed on chain, and then they're going to have those block headers or whatever to kind of look for it, and then store that and deliver that as a content delivery network. So that's really the vision I'm seeing. I think Craig talked about that too. And again, it all kind of ties back to Metanet, because when I was kind of thinking of all this, it's basically all mapped out. So I think we're kind of in a kind of transition period. But what I'm trying to bring to light is the need for infrastructure to finally reach parity with the mainstream enterprise world, right? So this notion of Raspberry Pis and running your own node is just absolutely ridiculous. You have to have enterprise grade servers. You've got to have dedicated circuits. You've got to have 100% uptime SLA with your bandwidth provider, et cetera. And so as folks get involved, and there's a need for these services to host NFTs or whatever, then you'll have these business models that can be created. But the hash part, I understand the thinking behind it. I could say that there's a lot of folks doing that. I know within EOS is kind of another chain that I've been following for quite some time. And to me, the ultimate differentiation is the fact that it's not on chain, right? And there's actually a company called Blockbase that it was like funded by the European Union, and they're doing something similar where they have a storage platform that everything corresponds with the hash. To me, I just see the value of you have one copy that's immutable, it cannot be copied, and then you can essentially start to build out either royalties from that. And in theory, right, one copy of a file, anyone can have that copy if it's on the blockchain, right? It's just a matter of who wants to, who's incentivized to deliver that or to host that long term. So I'm, like I said, I'm getting involved with some of the hardware to try and start testing and playing around just with my own money. And I don't know if you guys saw the conversation on CryptoBits with the founders of Saito. I know Saito's been making a lot of waves recently, and what those founders envisioned was the same type of system, but incentivizing with the token itself to pay for those services. I don't know if you guys saw that, but it sounds kind of cool at first. In my opinion, at the end of the day, it's very centrally planned. And I think that all of these kind of folks who are going to be coming on and providing infrastructure, it needs to be organic, and it needs to have a business outcome that's tied to it. And if you try and compensate folks with tokens for each little thing, then how can you define even what is necessary in terms of setting the
they should contract directly with their users, right?
I don't know if you guys had any thoughts about this Saito or if you've heard of it.
I mean, they should.
but
I haven't heard
Funny
of it.
thing, Jack Liu was talking about this in 2018 to me.
Who's that?
So in 2018, he was trying to pitch me this project. It's a
Who
long
was?
time ago. Jack Liu
Jack,
from
Jack Liu.
Jack. Yeah,
Relay
Relay
X.
X.
Okay.
Relay X. Yes. So it's been around
Oh,
for
Jack.
quite,
Yeah,
quite
yeah.
a while.
No, yeah.
For quite a while.
He's awesome. Yeah. If you listen to his episode on Crypto Bits, that was one of the most profound things I've heard in a while. So he's definitely a visionary. Yeah.
Mhm.
Cool.
Yeah,
funny.
just go ahead.
No, go ahead, Joe. Yeah, go ahead.
Yeah, just I want to say something quickly about the NFT. So it's like all the other like I would say healthy debate of whether the data should be on chain or is the hash of the digest of the hash should be on chain only. So for me, I think that's not like a maybe like a one size fit all answer, right? So if I have something very to me, I think again for me, I see it always economics, right? So if the benefit, if I put the doesn't matter how big it is, right? If the benefit weighs more than the cost, I would definitely put it. Otherwise, I would choose not to put it, right? Especially on a large scale, right? For example, right? So if I want to do some art, I don't know, this is like only unique art. I bought it for like $10 million, some kind of like a unique JPEG or rare. I want to make sure I always have it. It will not get deleted. Like and it only cost me $1 to host on BSV. I'm saying like, why not, right? But versus the other, let's say we record this Zoom meeting, right? It's 2 hours, usually 700 megabytes. If it takes me, I don't know, $100 to upload it, at least for now, right? It doesn't make too much sense because I can upload it to YouTube or Streamality for free, right? So it always boils down to economics. And the good thing about the SV is the only chain that can give you the other option to host it if you choose to put it on chain, right? So it's not necessary, but it's the only chain which I know can kind of make sense to put even the regional copy on chain. No other chains can do that as far as I know. So just something quick.
Yeah, definitely. And like a few weeks, I've been doing this survey over the past few weeks about that Section 7, the reclaiming the disk space. So and I was also talking to a few of the miners, and they're not really worried at this point in time because the size of the data isn't that big and the space is cheap. But over time, like if we go to Terranode and so forth, like there would be a time where we would start reclaiming the disk space, and with the SPV and the market proof and the block headers, we can start distributing this data to the users itself. So like if I publish the data to like on chain, but it's my own data, then I can again now start downloading from the mined blocks the same data, and then start saving it with the market proof and the block headers, and start maybe start distributing among the. And that's why I was mentioning, is there a way we could tokenize this, or does it even make sense to tokenize it, or because we can start distributing these mined like data that's now on chain, and you can validate it, and along with the market proof and the block headers, I can send my file, like my photo, my images trustlessly within the SPV network. So if I want to send, and that's going to be so cheap because now it doesn't have to be mined again. Because it's already mined. So if somebody wants to change it, then they have to now broadcast to a new transaction, right? So if I produce some music or for say some kind of art, and then it's mined now, and then mined on a block, and I can download it. I have all the proof that it's mined. I can distribute that to somebody else, and then if they want to change it, then they will have to pay some fees and mine it again, so that they can they can they can take the ownership for the new data, but the old data also will have value. So how do we, I think this kind of business will start propping up in the future.
Yeah, you're absolutely right. That's kind of the vision I'm seeing as well, is that how can we leverage SPV, right? Channels, payment channels, the smart contracts piece, because what I'm seeing is kind of like you're saying, right? You'll have one copy of a song, for example. That is immutable, it can never be copied, but then you can start to distribute that. Maybe you could do a per second streaming smart contract through that channel, payment channel, and kind of monetize that on top of that, right? So I don't think tokens are really, I mean, tokens are, you're kind of complicating the problem, right? There needs to be a use case. There needs to be kind of someone who wants that information. And what I'm envisioning is just more of a decentralized content delivery network, right? Because if you look at right now, for example, Microsoft Azure, I was looking the other day, there's only, I believe, like 16 or 18 availability zones within North America for all their content delivery, right? With Bitcoin, you could start to have folks coming online with infrastructure and start to host very much, regional and very specific in terms of what they're hosting and provide some real value. And I'm seeing that in the future, everything's going to be per second streaming, right? So, there's a lot that,
And also,
you know
like,
what I mean?
tied to your point, like, does it make sense to store this data and just publish the hash? Because now, like I was mentioning, because now you start distributing the trust versus, if it's already mined on a block, and say a business, say Netflix, wants to download all of these files and start distributing them, they have all the proof, they have all the proof, they have everything. So with anybody, and they can just distribute this JPEG or on the movie itself to anybody, any user, any other person. And I think the overlay networks, in my mind, from a business standpoint or from even an economic standpoint, should be like, everything should be on chain first, and then you start down the
No,
down the line.
That definitely makes a ton of sense. Yeah, definitely. And again, I'm not super technical in terms of, these are just kind of some visions that I have, and hearing Craig, and a lot of it's kind of similar. And then what you guys are saying makes a ton of sense, and I think is really smart. And what Ty's building out is phenomenal. So I find it fascinating.
Cool.
Yep.
I think
we're coming up to the end here.
Yeah, it's almost more than 2 hours. So any quick final thoughts, or we can just continue next week?
Yeah, I'll keep
I'll
keep submitting some ideas on Slack, and people can read them if they want.
That's great.
For those who are interested in Bridgeport, Shamir and I had a really great conversation.
Oh,
so
yeah,
you can
okay.
find it on my
I
channel.
saw a couple minutes. I'll watch the whole thing.
Okay.
Yep.
Yeah.
People who are interested about that can check that out, is what I would say.
Okay. All right, guys.
Awesome. Thanks, guys.
That's all for now. Thanks for coming. Thanks, Mike, for joining us, and we'll see you all hopefully next week. Have a good weekend, guys.
Thank you.
All right. Thanks,
Take
guys.
care.
Take
See you
care.
again.
See you guys soon.
Okay. Bye-bye.
See ya. Bye.
See you around. Bye-bye.